Hello and welcome to HelpYourMath.com. In today's video we're going to be talking about trigonometry. In this problem what we're going to be dealing with is setting up the problem and solving for a missing component of the problem. So let's take a look at our series of questions here. We have two questions. The first one says, at a point of 30 feet from the base of a tree, the angle formed with the ground looking to the top measures 88 degrees. Find to the nearest foot the height of the tree. Now when we're setting up this problem, what we want to do is get a clear illustration of what's happening with it. So when we see this saying, at a point 30 feet from the base of a tree, the angle formed with the ground looking to the top measures 88 degrees, we know we're looking at a point that measures from a base of the ground to the top of the tree, right? Because at a point 30 feet from the base of a tree indicates 30 feet from the bottom of the tree, which is over here, to here. And then it also tells us the angle formed with the ground looking to the top measures 88 degrees. So from 30 feet from the base of the tree, we see an angle forming to the top of the tree, which lets us know that this angle is 88 degrees now. Now from this information, we're to find to the nearest foot the height of the tree. If we want to envision anything about this thing here, we could say this is the tree over here, right? Here's the base, the trunk of the tree. And the distance from here to here to this point is 30 feet. Now what we're looking for is the height of the tree. So we'll call that side H. And to solve this, what we're going to use is trigonometry, right? So what we have here is the side opposite to the triangle's angle. The opposite side of the angle is the H. The adjacent side of the angle is the 30 feet. And this is the right angle here, making this the hypotenuse side. Now what we have here is the opposite and the adjacent side formed with an angle. So what we can use here from the term SOHCAHTOA is the tangent side. And the tangent side says the tangent of the angle is equivalent to the opposite side over the adjacent side. So let's set up our equation from this formula here. And we know that our tangent, our angle's value is 88 degrees. So we have tangent of 88 degrees is equivalent to our opposite side of the angle is H, and our adjacent side of the angle is 30 feet. Now to solve this problem, our first step we're going to take, since H is the numerator, we're just going to multiply both sides by 30. When we do that, we're going to get 30 on both sides. These 30s cross away, and we have 30 times tangent of 88 degrees. So H is equivalent to 30 times the tan of 88 degrees. Now, for those of you watching this video, I'm hoping that you're using a calculator, because this component of your exam is going to be calculable. So you have to make sure you're using a calculator to get your result here. So what we're doing is we're taking 30 and we're multiplying the tangent of 88 on our calculator, making sure that we have our mode set to degrees. Because when we take the tangent of 88, it has to be recognized by degrees on your calculator. Once we do this, we do 30 times the tangent of 88. We're going to get H is equivalent to 859.08759.849. And this number we have to round it up, because the solution says round this to the nearest foot. And the nearest foot indicates that it needs to be the nearest whole number. So we're going to say H, or the height of the tree, is 859 feet. That's our solution for the first problem. Now looking back at this solution, we see the height of the tree is actually 859 degrees. So our illustration here might not be accurate, but it is useful and helpful in identifying the sides of the triangle. But if we want a real illustration of what this should look like, because it's only 30 feet from the base and the height is way higher, the ratio from the base to the height is very, very steep. So we know the angle is also 88 degrees, which is close to 90. So this is actually going to be a very short distance and a very long way up. And this will be our 30 feet down here. Our 859 feet will be here at the base of the trunk. And this will be our angle of 88 degrees. And this is for more accuracy, to avoid the confusion that we have a very small tree when we see it's 859 feet. It's actually very, very big. All right? For our second equation, or problem here, we have an observation tower, which is 75 meters high. A support wire is attached from the ground to the top of the tower, forming a 55-degree angle. What is the length of the support wire to the nearest tenth of a meter, right? So here what we're looking at is, first of all, we have an observation tower, right? We have a tower, and at the top of the observation tower, there's a support wire attached from the ground, forming a 55-degree angle, meaning this goes out somewhere like this. We have our angle here, 55 degrees, right? And we also know that the observation tower is 75 meters high, so this side is 75 meters. What we're looking for is the side of this, the support wire, right? We'll call that side S because the support wire is S for support wire, right? And now what we have to do this is use one of the trigonometric functions to solve what we're going to get. Now since here we have the opposite side of the angle, and the hypotenuse, the best and most convenient form to use is the sine value, right? Because sine in SOHCAHTOA is sine of theta equals the opposite side over the hypotenuse side. And we know here the hypotenuse is the opposite side to the right angle, and the right angle here forms with the opposite side of this right angle is the S side. So if we start with our equation, we have sine of 55 degrees, which is our angle, is equivalent to the is equivalent to the value of the opposite, which is 75 meters, over the S, which is the support wire side, which is also the hypotenuse in this case. So in this case, to solve for the support wire, we're going to multiply both sides by S and divide both sides by the sine of 55. So first we multiply by S. That gets rid of this and this. So now we have S times the sine of 55. And then to solve for S, we're going to divide by the sine of 55. And this helps us isolate the S term. These two will go away. And now we have the solution for S. So S is equivalent to 75 divided by the sine of 55 degrees. And again, we want to calculate this. Make sure your calculators are on degree mode, right? When you're doing either radians or degrees, put it in DEG in your mode, and make sure you divide this as 55 and not radian form. So now we have 75 divided by the sine of 55 degrees, and 75 divided by the 55 degrees will give us 91.558094157, right? And now what we have to do then is round this to the nearest tenth, because that's what the question is asking us. So the nearest tenth is right here, this position, and we're looking at the next digits around this one. This is 5 or greater already, so we're going to round this 5 to the next number. So S equals 91.6 in meters. And that's our solution. Thank you for watching.